presentation. All right, good morning, e-learners. All right, once again, any questions? This was a review. Remember, we're going to be doing, there's generally one of these per chapter. There's never two, but there's typically one of these per chapter. There's maybe 3 or 4 chapters that don't have it. Most chapters have an algebra review. And its purpose is typically the very next class, or if it's at the end of the chapter, the next chapter will involve that algebra technique. So this algebra technique will just solve equations. And not a single person has a question. Well, that's good. Okay. Go ahead. All right, and I already know you graded your paper yesterday. All right, here we go. Number 2, c equals 5. Number 4, z equals -6. Number 6, x equals 7. Number 8, x equals -5. Okay. Number 10, a equals 6. Number 12, a equals -25. Number 14, b equals 3. Number 16, k equals 7. Number 18, k equals 4. It's 4. Negative divided by negative is a? Yeah. Number 20, e equals -27. Number 22, p equals 4. Number 24, p equals 5. Number 26, r equals 7. Number 28, x equals 9. Number 30, x equals 1/2. Remember, you're in big boy, big girl math now. We leave fractions as fractions. We unless the instructions say give me a decimal approximation or a decimal equivalent number, we leave fractions as fractions. They must be reduced, but we don't change fractions into mixed numbers. We don't worry about it. Even if it's an improper fraction, life is good. 32, u equals 3. 34, x equals -17. 36, z equals 20. 38, c equals 6. 40, x equals 30. 42, g equals 12. 44, d equals 16. And the last one, y equals 360. All right. Passer out and collector. There's the box right there. Somebody grab it and somebody pass out the paper. Yeah. Thank you, Chris and Matt. One person passes out the paper. One person walks by with the basket, collects the homework. Which is why I need 2 people. Which is, there you go. All right. For the rest of you, here, quiz tomorrow. All right, here are the answers for the quiz. How many points define a line segment? How many points are on a line segment? Infinite, right? There's an infinite number of points between. Like 2 points define. How many points define a line? How many points are on a line? Okay. How many points define a plane? 3. There's some other things, but they're pretty easy, and then the rest will be on today. Okay. Typically, the first quiz I will have students, even though I literally just gave you the first answers on the quiz, will still do poorly. So if that went too fast for you, ask your neighbor. See me for student advisement. Here's your homework for tonight. So you're going to do 2 things. You're going to do homework and study for a quiz if you need to study. If you remember the slide that I had on, I said I never studied for geometry. That's not a challenge. I'm just saying, if you understand what's going on, geometry is about logic. It's hard to study for logic. You're either logical or you're not. If all of that made sense, you don't need to study how many points to find a line, too. It's like you learn it once and it'll stick with you for the rest of your life. It's also open notes. Today we will take our first, not that we haven't been doing math before now, but really today is our first notes that will go in our book of knowledge. The notebook that you have in front of you, right? You can't lose this. All of the notes have to go in this notebook, right? If you have a little tiny notebook like this, that's fine, but I need you to make this your notebook of notes. You will fill this full of notes this year. You don't want to wait in third quarter, and I say it's open notes, one notebook, and you need an extra notebook. So what I would recommend is, we're going to use this. I'll tell you how to set up here in a second, but leave this just for your notes. Do your homework on a separate sheet of paper. Makes sense? Okay. Today I consider like the very first day of, hey, we're in it. The rest was kind of get ready. Now we're in it. The fight's on. Okay? Here we go. So segments, rays, and distance. All right, rays and segment, kind of a holdover from the previous class. Distance is the, hey, welcome to geometry. You're going to see that everything I've said so far is true. I said two basic things. I said the math and geometry is really easy. 4 plus 2, that sort of math. And then I said it's logical. So you're going to see both of those today. One, you got to understand the logic when you do the homework, especially. And then two, you're going to see that the math is ridiculously easy. Yeah, there'll be a little bit of algebra today, but boy, is it easy. A whole bunch of things and some weird words. I will tell you what they are when we get to them. Here we go. Recall from previous class. We call this a point. Right? Point is just a location. It's not a physical size. It's not a shape. Right? It's just a location in space. Yeah. Well, then who was passing out? Chris? Did you give one? All right. We name points by what kind of letters? Capital letters. Just remember, capital letter can be anywhere. Doesn't have to be on top. It could be this side. It could be way over here. If it's way over here, there's going to be an arrow pointing to the point. Okay? We talked about space. Space is the collection of all points. You put all the points all the locations that are possible, you have space. We talked about if you have 2 points, and if you play connect the dots, you make a line segment. And you can just say segment, that's just fine, that's fine as well. And that is why we say that 2 points define a segment. There's only one segment that joins, there's not 2 segments that join those 2 points, just one. So 2 points define a unique segment. 1, there's an infinite number of segments I can draw through B. But as soon as you put 2, there's just 1. It's the first question on the quiz tomorrow, I think. Maybe it's 2. How do we name segments? Which 2 points? Because remember, we could have point C right here. Right? Here's point C. It's 2 endpoints define it. Does the order matter? Order does not matter. So segments are named by the 2 endpoints. Order doesn't matter, with a line segment over the top of it. Okay? Good? So this is A, B, or pretty simple. Right? So this is the long segment there is. The short segment there is. And the medium one is. And all the possible combinations thereof. You could say XY is the short one, or YX. The medium one is YZ or ZY, and the long one is XZ or ZX. Okay? Review. Here was the first, okay, geometry is stupid common, right? What's the name of the segment? Okay, if I want to show you how long it is, how do I write that? Without this portion right here. So if I want to say that's 2 feet long, I leave that off. We're going to be seeing that today. We're going to see both of these today. When you get the homework problems tonight, it's either going to look like this, or it's going to look like this. If this is what they're asking you, they want to say how long is it. If they're saying this, they're going to talk about something called, we'll talk about here in a second, congruence. Okay. New one, box 1. The shape that, I don't know why, in most books they go point, segment, ray, line, but ours goes point, segment, line, then ray. A ray is made up of one endpoint and all the points that go in an opposite direction. So in other words, it's made up of X, that's the starting point, and I'm going to go in one direction forever. A lot of people would say, well, it's half of a line. Okay, I understand why you would say that. One problem. If you have 1 point, listen to my question. If you have 1 point, how many rays can you draw through it? If you have 1 point, an infinite number of points. So therefore, we can't call this ray X. What do we need? What?
Logic.
Here we go. This geometry. If an infinite number of rays goes through one point, how many points do I need to define that ray right there? Well, there's one right there. But this ray also goes through there. I need two. Where does the second point have to be on the ray? Anywhere. Why? Because it goes on forever. Segment has to be the two endpoints. But for lines and rays, same thing, you just need a point anywhere on the ray. For instance, that one right there. This could be anywhere. It could be over here. It could be right here. This arrow means it goes on forever from X in this direction forever. So you need 2 points. So nearly every single question, how many points define this shape, with the exception of plane, it's 2 points. 2 points define a line segment, 2 points define a line, 2 points define a ray. Okay? How do we name rays? And now I did teach you this in pre-algebra.
I don't remember what the line thing on the top is, but it's X, Y.
Okay? First off, which direction does this go? Where does it start? It starts on X and it goes in that direction. So what would be the logical way to name this? Why would it be wrong to say YX? It doesn't go in that direction, it goes in this direction. The segment or the ray is the only one where the letters, order of the letters matter. So this is ray XY. X, the first letter is where does it start? The second letter just tells you the direction that it's going. What's on the top of it? A ray. Which way does this ray face? Which way does this face? Except that means absolutely nothing, right? What happens if the ray goes straight up? Well, you're certainly not going to draw the arrow pointing straight up, right? All designators for rays point to the right. Go figure. So it doesn't matter which way the ray faces. When you label it, the ray on the top of the 2 letters faces to the right. Okay? All right. So this is not ray YX. Why? No pun intended. Get it? No? Okay. Why is it not ray YX? It doesn't start at Y and go towards X. Hey, this is a segment. This is a segment YX. The ray starts at X and goes in this direction. So that's why it must be XY. YX means the ray that goes in this. Oh, it doesn't continue. It stops right there. What's the name of that ray? The red one. Okay. Why not YX? Because it doesn't start at X or start at Y, it starts at X. Can everyone see that? Okay. That's usually your rookie algebra or geometry mistake the first week or two, is that you just simply label your rays wrong. We're going to have lots of rays this year. We're going to have lots of line segments, lines, and rays all the time. We good on rays? Pretty simple. Chandler, how many points make up a ray? How many points make up a ray?
2, 1.
When I say make up, I mean if you were to build a ray, build it literally, and when you're done, it looks like the ray, how many points would you need? So you're saying that that's a ray. Is that a ray? Does this look like this? I mean, literally, I'm saying literally, does this look like this? You told me 2 points make up a ray. I just drew 2 points. Does this look like this? Just infinite. So this is the thing you got to wrap your head around. The 2 questions are how many points make up a shape and how many points define. So how many points define a ray?
2.
There you go. Boy, you guys better get that right on the quiz. Okay, now here's an interesting fact. Lines have lots of rays in them, right? Because lines go on forever. How many different rays do you see right there? Liam, give me a name of a ray that you see right there.
Y.
Remember, rays are named with how many letters? 2 letters. I need 2 letters. He sees ray XY. That's the one that starts here and goes in that direction forever. What do you see, Seth? XZ starts here and goes in that direction forever. Is there another ray there that's different than those two? What do you got? ZY starts here and goes in that direction forever. Is there another ray? What?
YZ.
YZ starts here and goes forever. Notice these look, as I drew them, the same. They're different. This one goes over there forever, never stops. This one goes over here. Those are 4 different rays right there. 3 points gives you 4 different rays. Crazy, right? Hey, when are we actually going to do math? Adding numbers? Rarely in geometry. Okay. So, and this was basically, I was just showing you the difference between those. I want you to look at those 2 rays right there. XY and XZ. What do you notice about those 2 rays? They start at the same point, right? They both start here, but they go in what direction? Opposite directions. We have a name for that. Rays that start at the same point and go in opposite direction. Take a guess. Put them together, you made a line. We call these 2 rays, take a guess. They go in opposite direction, so guess what we're going to call them? Opposite rays. Opposite rays start at one point and go in opposite directions. You put them together, you make a line. Okay? Easy concept, yes? Nothing hard so far. Okay, here we go. And by here we go, I mean like here comes the geometry at you. All right, we call the rules and the laws of geometry, instead of calling the rules and laws, we give them special names. There's 4 of them. They will all go in this book right here. Everything from now on will go in this book. So when I say write this down, it's not going to say box 1 anymore. I'm going to say put this in your book. By book, I mean your notebook. Here's my recommendation. You don't have to follow me. I would go to the very last page, and I would start there and work backwards, right? And that way, you have if you have a very thick one, right, you can still do your homework in the front, and in the back, you got all of your knowledge. You don't have to take you can interchange it, but then you're going to be flipping through a lot of stuff trying to find these rules and laws, okay? So take my advice or not, it's up to you. Anybody remember from previous classes what do we call the rules and the laws of geometry? There's 4 of them. Euclid called them the same thing, sort of. He called them definitions. You don't need to write this down yet. Postulates, theorems, and corollaries. Okay, well, I kind of know what a definition is, but the rest of the stuff I have no idea. I will tell you, right? The first one, well, is definitions. Easy, right? We've done a couple definitions. Trust me when I say they don't need to go in your book of knowledge, right? Which is what I call your book. Postulates and definitions are the first 2 things we're going to do. Definitions are straight up just, I'm going to define something, okay? Postulates, I said we're going to prove everything in geometry. Postulates are the duh statements in geometry. A right angle has 90 degrees. That's a definition. Any two right angles, right, have equal measurements. Why? Because of the definition. That's a postulate. That's going to be a statement that I make that we accept as true because duh, right? It's a simple statement. Theorems and corollary we'll get to, I don't know if it starts tomorrow or the next day. All right, so write this down. Right? I'd say this in box 2. It doesn't need to go in your book of knowledge because we're going to be dealing with these all the time. A postulate. I distinctly remember learning this in high school and saying, I will never know the difference between a postulate and a theorem. And after the second week, I was like, okay, I was full of it. Now I understand the difference. But the first day, you're probably going to be worried. A postulate is a statement we accept as true without proof. I'm trying to think of something funny to say, and I'm falling short. Seth will always ask a question every class. That is a statement that we accept as true. Now he's going to be quiet for a class and prove me wrong. Oh, I like that. All right. These are going to be really, really, really simple duh statements. Well, duh, of course. A whole is made up of its parts. Duh, right? I'm not going to prove that to be true. We know that's true. Some books call postulates axioms. Our book occasionally, they don't call them, these are going to be numbers, by the way. They're going to be postulate 1, 2, 3. I don't know what number we go up to, but probably in the 20s or the 30s we go up to. Way more theorems than postulates. Okay. Theorem is the second one. Theorem are statements that I got to prove. Micah gets higher scores than Seth on all of his tests. Yeah, I got to see some proof for that, right? Certainly wasn't true for his chemistry test. Right? We got to show some proof for that. So we will be spending the majority of our time on these things called theorems. And it sounds like theory. You got to prove theories, right? We prove theorems. We do not accept them as being true. The sum of all the counting numbers is -112. Heck no, you better prove that to me. Postulates we accept as being true. You're going to see when I give them to you. They're obvious statements. Theorems we will prove. We will not see a theorem today. We will see a couple postulates. We all right? We didn't put this in our book of truth because these are just statements. The last one and the hardest one, I should say the hardest one to remember what it is, are these things called corollaries. I know my college geometry teacher said corollaries fall from the tree of the theorem. I'm like, what? Corollaries are theorems. We have to prove them to be true, but they come directly from a specific theorem. I'm going to give you a theorem, Pythagorean theorem, right? Remember that one? No one proved it to you. We will prove it this year. There's a corollary to a Pythagorean theorem. It comes directly from the Pythagorean theorem. So if there's something I need to prove to you and it comes directly from one of the theorems, we don't call it a theorem, we call it a corollary. Don't get hung up on any one of those three names, you'll be fine. Even if you go to the end of the year and you still couldn't tell me the difference between a postulate, a theorem, and a corollary, that has nothing to do with logic, they're just names. So on day one, this can be a little intimidating, but trust me when I say this is not the intimidating part. We okay? All right. So all I was basically just defining I didn't give you definition because that was the obvious one, but we're going to have definition, postulates, theorems, and corollaries. Okay, let's see some of these. Today we're going to be talking about distance and measuring, right? Measuring distance. What's a ruler? Which I said we would not use in this class. What's a ruler? No, what's a ruler? Well, a ruler could be used as a straightedge, but what is a ruler? It's a device that we use to measure things within. And remember, that wasn't part of our required list. We got to define what a ruler is. So, distance, right? A ruler is kind of like a number line, yes? Right? A line. We can make this a number line by putting numbers on it. How do we determine where those numbers go? Is it arbitrary? Do we just make that up? Heck yeah, we make it up. We literally make it up. I mean, rulers don't grow from the ground, right? We literally just make it up. Somebody said this is an inch, right? And said that the length of, I forget which finger they used. I want to say it's a thumb, but I could be wrong. The length of a certain portion of the anatomy was used as a measuring device. And from there, we got all our measurements from. So in geometry, here's how it's done. We take a line that has 2 points, could have 50 points. We pick 2 of those points. We make one 0. We make one 1, and there's our number line. There's our ruler. Literally, it's that arbitrary. You take any line, put 2 points on it. You make one 0 and one 1, and there's your number line. Well, how do you get to 2 then? Remember, we can take our compass and we can measure how far it is from here to here. We transfer that to here, and now we have 2. How do we make -1 or 0? Well, we do it to the other side. If this is 0 and this is 1, we go over here and there's -1. There's where our numbers come from. And there's where rulers come from. Literally, that's it. Okay? Write this down. We said postulates are things that we accept without proof. What I just said to you should have been obvious. All right, so this goes in your book of truth, not on your sheet of paper. The points on a line can be paired. Remember, I gave you a line, I put 2 points. The points on a line can be paired with the real numbers in such a way that any 2 points are 0 and 1. I just arbitrarily picked 2 points. But as soon as I pick those 2 points, one becomes 0, one becomes 1, there's my number line. I create the rest of the number line from that one measurement. This is called the ruler postulate, and it's Euclid 1. The points on a line can be paired with real numbers in such a way that any 2 points can have the coordinates of 0 and 1. Rulers are arbitrary. Somebody came up and said, this is what we're going to call 0, and this is what we're going to call 1. Once that's done, you can make all the numbers to include decimals and fractions. How do you make a half? What's a half? Don't overthink this. What's a half? It's halfway between 0 and 1, right? Continue to cut that in half, you make more fractions, a quarter, an eighth, a 16th. This is called the ruler postulate. Okay? How do you... Okay, moving on. Well, then how do you calculate distance? Like if I ask you to measure something, what do you do? Like literally, what do you do? How long is this piece of paper? What do you do?
You put your ruler up to and measure it.
What part of the ruler do you put up to it? No, but what part of the ruler? Do you put 17.35 on the first part?
No, 0.
You put 0. Okay? So here is a number line with various points on it. The ruler postulate says you got to pick 2 of those, make one of them 0, one of them 1. Okay, I did that. From there, I make the rest of the number line. What's this number? What's this number? -1. So I've got my ruler, right? So now what I can do, I can measure, right? How far is it between, right? Oh, this is how we make fractions, right? If I make, instead of this one to be 0 and this one to be 1, then what's this point right here? There's your half, right? 0.5. So you take 2 points, you make 1, 0, you make 1, 1. How far is it between point A and point B? How far is it between point A and point B? Well, I got a sign a 0, I got to sign a 1, create the rest of the number line, and then literally, how do you find how far is it between A to B? You're saying count the dots, right? If I start right here, I'm going right here. How far is it? It's not 3.
1 dot.
It's not 1.
2.
It's 2 dots. It's if I start here and I'm going, I start here, I'm going here, I'm starting here, I'm going there. 1, 2. Well, that's a pretty easy thing to do when I'm only going 2 dots. What if you're going 56,000 dots away? Is there an easier way using math to find this out? You can see the numbers. How far did we say is it between A and B? I said it's 2.
Difference.
Go ahead, finish the thought. Finish the thought.
You just subtract.
Subtract what?
You subtract the, no, but,
You're there. You just got to finish the thought.
yeah, you take the difference.
The difference of what?
Between the first number and the last.
Between the 2 coordinates of the points. Hey, what's the coordinate of point B?
3.
What's the coordinate of point A? So to find how far is it between the distance between A and B, what do you do with the 2 numbers? You subtract them. That's it. You just subtract the numbers. This is where subtraction comes from. Remember I said we would accept nothing in geometry till we prove it? I just proved it to you. That's where subtraction, that's also where addition comes from. There's one slight problem with this. If we follow this method, how far is it from A to B? Well, you said take the two numbers and subtract them. So now if instead I go from A to B, well, technically that's 1 minus 3 because you said subtraction. 1 minus 3 is not 2, it's, so we got to put one slight change to that. How far is it between any 2 points? Clearly not -2. It is the absolute value. It is the absolute value. We say the difference between any 2 points is the difference, is the absolute value of their difference, right? Remember doing absolute value? You get an answer, and then you say how far is that from 0. That's how you do subtraction. That's how you do addition. That's also how you do multiplication, right? Remember, multiplication just repeated addition. That's how you do exponents. Exponents is, once again, repeated multiplication. Okay? I just created for you, and division is the inverse of multiplication. I just showed you how to abstract, multiply, and divide. We got that out of the way. We're ready to move on. Write this down. This is also part of the ruler postulate, so it's the second statement. Once you make this coordinate system, which we just did, the distance between any 2 points is the absolute value of the difference of their coordinates. That's literally what I just showed you. You want to find how far it is between A and B? You take the coordinates, you subtract them, you take the absolute value. You're like, wait a minute, I can just count dots. You can. But once again, if the first dot is at 46 and the second dot is at -351, you're not counting dots. You're doing this. You're taking their 2 coordinates, you're subtracting, taking their absolute value. This is nothing new. This is, you already know this. If I give you 2 numbers and I say subtract, you already know how to do that. But in geometry, we prove everything. So I just proved you addition, subtraction, multiplication, division, and technically exponents and square roots as well, too. All of those are just a form of what's called arithmetic. This is where we get arithmetic from. A number line and messing around with numbers. And this will be the easiest postulate of the year. It'll also be the one postulate that we almost never refer to. The rest of them we refer to frequently. This is the one that kind of gets no love. But this is also what allows us to do our basic arithmetic. Once a coordinate system has been chosen, the distance between any 2 points equals the absolute value of the difference of the coordinates. What calculation did we literally just do, Chandler? What was the math that we literally just did? What numbers did we just mess with? The previous slide, what numbers did I literally just do? 1 minus 3. I'm not lying when I say that math and geometry is ridiculously easy. It's the logic that's going to kick your butt. All right. I think that's pretty cool. So this is why you can abstract, multiply, divide. I just said that. All right. Sometimes in geometry, it's weird and hard. All right. That concept was a little bit weird as I was describing it. At the very end, you're like, okay, I get that. Other times, it's simple, stupid, and obvious. Postulates are simple, stupid, and obvious. Let's see one. I call these the dull ones. Remember, we can't do anything in geometry unless I prove it to you. Postulates are the one exception. We accept those as fact. Okay? Postulate 2. This is in your book of truth. This is called the segment addition postulate. This is a dull one. I'm going to give it to you. I'm not going to prove it to you because you'll see it's obvious. Or it should be obvious. Okay. What shape do I have? A line segment. Okay? I'm going to cut this segment and I'm put another point on it. Now it's the long one has a third point on it. You see that? But I'm going to consider the long one. All right. Who wants to do the logic? Somebody hasn't spoken today. How far is it from A to C? There's no number line. There's no numbers there. How far is it from A to C? Think that question through. How far is it from A to C? And when you see the answer, you're going to say, well, duh. That's obvious. It's literally going to be that easy. But I might have to explain it to you. Wes, how far is it from A to C?
Is it infinite or is it B?
It's not going to be infinite. The number of points is infinite, but how far is it from A to C?
B, right?
Oh, well, this is B distance right here. And clearly, it's at least double that. It might even be triple that. How far is it from A to C? Somebody knew. Come on, one of you guys can get this. And I'm not looking for it's 17. Logically look at the picture and tell me how far is it from A to C. Like there's no numbers there. How could I do this? Watch how simple geometry can be at times. How far is it from A to C? It's whatever the distance A to B is plus B to C. This is called the segment addition postulate. You want to know how long that is? Add up its parts. That's all the segment addition postulate says. If B is between A and C, then add this part to that part. That's it. That's the whole thing. It's AB plus BC, and that's going to equal AC. You need to write this one down. This is the first one that you will use a lot. You're like, wait a minute, literally, that's it? You just add up the parts? Yes, literally, that's all you do. Duh, right? Do I need to prove that? No. How far is it from me to the wall? Well, it's whatever the difference from me to Seth is, and from Seth to the wall. You add those two numbers up, and that's how far is it from me to the wall. Tonight for homework, guess what they're going to do? You're going to have numbers. And then you're going to have to do what with those numbers? That's it. Now, they will throw a couple variables. You will have to solve an equation or two. But that's all it says. Who's lost? Hey, if this is 3 and this is 7, how far is it? That's it. So here's a quick example. If B is somewhere between A and C, and AB is 4, notice, what do I have missing right here? There's no line. That's why it says equals. So it's equal to 4, I don't know what, inches, centimeters, whatever. If AB is 4 and BC is 10, how far is it?
14.
Are you paying attention? Is geometry hard?
No.
Not yet, right? So this would be like a question I'd give to a 4th grader, right? Right? But this is geometry. So AC is 14. Sometimes in geometry it's weird and hard. Sometimes it's stupid, simple, and obvious. That one is one that's stupid, simple, and obvious. Right? To make it slightly more challenging, what will they do? They'll throw variables in there. Check it out. It's the same problem, just with variables. Okay, let's put our thinking caps on. What does this say right here? Oh, by the way, this is your box 3. What's that say? Is that a piece of it, or is that the whole darn thing? That's the whole darn thing. How big is AB? It's X. How big is BC? So what are you going to do with these two things? What's the segment addition postulate say? The whole thing is equal to this thing plus this thing. So let's write that equation. How big is this? Write that down. Plus, how big is this? And that's supposed to equal 24. Somebody's already simplifying. See what I did? The small piece plus the medium piece equals the whole piece. The small piece is X. The medium piece is X plus 6. And the large piece is 24. Could you solve that?
Yes, sir.
Right? Did you do that last night for homework? That's why you did that last night for homework. I'm going to skip through this really quickly, but you've got to stop me right now. You're like, I'm lost. Nobody's brave enough to say they're lost because you're probably not lost. So let's see, I got 2 X's, so that's 2X. Subtract 6 from both sides. Divide by 2, so X is equals 9. And I'm done, right?
24 divided by 2 is not 18.
Now you fill in A, B, and B.
24 divided by 2, I didn't divide by 2, I subtracted 6.
Yeah.
Okay. I'm done, yes?
No.
Because what does the question say?
AB,
How long is AB and how long is BC? So how long is AB? How long is BC?
9 plus 6.
Who's lost? Right? There's the answer. Who's lost? There's geometry for you. They're not going to tell you how to solve the problem. They're going to present you with something that you've got to logically think through using your book of knowledge. We know that the segment addition postulate says this piece plus this piece equals the whole thing. Right? This is a very easy one in geometry. They get much more challenging than this. This is the intro, nice friendly ones. But this is also why geometry is challenging, because as soon as it's explained to you, like, well, duh, okay, I see it now. Sometimes when you get started, you don't know what to do. Good job. That's from anybody? Supposedly the best movie of all times. Citizen Kane. All right. All right, next idea. Write this down in your book of truth. Congruent.
Why does it have a square?
Because you're writing it down. Remember, writing is write down. Okay, congruent. These are two shapes, except it says the word objects. Two objects that have the same shape and the same size. I mean, you can have a triangle and a rectangle have the same area, so that would be the same size. But they have to have the same shape and the same size. Same shape, same size. If they are, they're congruent. Who remembers the symbol for congruent? Symbol for congruent is an equal sign with one wavy line over the top. That means congruent. So if you need an example, here are two triangles that I literally just copied them. I made one red, one in blue. When two shapes have the same shape and the same size, we can put that symbol between them. Doesn't say that they're equal. It says their sizes are equal. But it says that they are alike each other. Now, if you have me, you've seen this symbology before 2 years ago. Hey, are these the same or different? Okay, this one is AB and this one is, so they're two different segments. Do they have the same measurements? Are they the same thing? Right, therefore they are congruent. We can say that AB has the same measurement as XY, right, because they're both 18. And we can put the little squiggly line with the line over the top to show that they're congruent. This is usually the hardest thing for geometry students to get used to. Okay? Their measurements are the same, the shapes are the same. Shapes and size. Okay? All right, we have symbology or markings for congruency. Remember what they look like? When one thing is exactly the same as the other. So if this thing is congruent to this thing, we can put markings on it to show that. You remember what the markings are for segments? It's a little tick mark, right? See that little red? And they're typically always red. We'll talk about angles tomorrow. If this is congruent to that, right? Can I put one tick mark? Why would I want to put two? So I don't confuse it with this one. Clearly this one is long, or this one's shorter than that one, right? If I had a third one, we put 3 tick marks. So you won't see more than, I think, 3 tick marks this year.
So we're using colored pencils?
We are, well, at least in the book, you'll see. And they're almost always red. Almost always red. Okay. If you have a line segment and that sucker right there is halfway between A and B, guess what we're going to call that thing right there? We won't call it the middle. We will call it A. If it's halfway between the two, we're going to call this point a midpoint. Okay? If it's literally halfway, if B is halfway between, we call it a midpoint. Write that down. And since it's on a segment, we call it a segment midpoint. We're almost done. What time do we get out of here? We get one more definition, we're done. 35. Excellent. Last year I screwed this up. I think I got sidetracked and I couldn't get this lesson. And I was like, it's going to be a horrible year if I can't get through this lesson. All right. Segment midpoint. How do we know it's a midpoint? Well, because AB is 5 and BC is 5. They're both on the same segment, AC. So is this one of those hard to understand one, or is this one of those stupid, simple, and obvious ones? This is one of those stupid, simple, obvious ones. And I shouldn't use stupid, but I'm just saying that there's plenty of things in geometry you're like, well, I could have figured that out myself, and this is one of those. So this is called a segment midpoint. Okay, so when I talk about a midpoint, you know what I mean. We okay? If the two segments equal each other, we're talking about measurements. Remember, we don't put a line over the top, we put equal. But if they're equal to each other, that also means they are congruent, right? So I also could say that those are congruent. Once again, I remember doing this when I was in high school, right? Getting used to equals and congruency took a week or two, right? All right, quick example, right? Wait, what's that red thing? That's a line. Could a line go through a midpoint? Sure can. Our book has a bad habit of when two things intersect, they don't put a dot. When two things intersect, they don't put a dot, right? There's no dot there. But is there really a point there? That M right there is, they put dots right there. Why didn't they put one right in the middle? Why didn't they put one right? I don't know. Well, I mean, they like to have their textbook, whose was it? They like to have their textbook or their diagrams not too complicated. I like putting dots, right? So I will generally put a dot. If this line goes to the midpoint, guess what we call this line? You can't call it a midpoint line. That would be weird, right? It cuts it in half. We are going to call it another word. You probably won't know this. But say it again. We're going to call it a bisector. This red line bisects segment AC. So we're going to call that a segment bisector. Now, is a line the only thing I could have drawn right here? What else could I have drawn? I could have made it a ray. I also could have made it another line segment, and I also could have made it a plane. So it could have been a line, it could have been a ray, it could have been a plane. Last one, and we're done. Write it down. Segment bisector. So it's got something to do with midpoint, right? B is the midpoint. If you have something, a geometric shape, that intersects that segment at its middle, we call it a segment bisector. So it could be a line, a ray, or a plane. Segment bisector. What number you want, Mike? Have I covered everything?
Yeah.
Oh. I better, because this is the last one. All right. What do we got tomorrow? We got a quiz tomorrow, first thing. I already gave you the first 4 answers. So what from today's class would I put on it? Well, some of these are the dull ones, right? Segment bisector, right? I'm not going to have a, word bank or anything, but I will put that one segment using the segment addition postulate, and I'll have you do a calculation. I forget how many of those you have tonight for homework. Just a couple, I think. Because I'm mean. All right. Opposite ray, remember that one? It starts at the same point and goes in opposite direction. Midpoint, duh, right? It's in the middle. Congruency statement, 2 shapes that have the same shape and size. Equality just simply means that they have the same measurements. Intersection, that's 2 shapes that come together, right? Could be at a point. Remember, 2 planes intersect at a line. And bisection just means something that cuts something in half. That's kind of what we did. Now, we also did the segment addition postulate. We will use the segment addition postulate plenty of times this year. Any questions on anything we did? I think we got 5 minutes left. That's pretty crazy. I finished on time. This year, and don't take this as a challenge to get me off track, but if I can't get through the lesson, I'm not giving you homework. I don't want you to try your homework. Well, some of you are going to want to try, but I don't want there's too much in geometry that you got to have the whole picture. I thought we had 5 minutes left. Didn't it say 8:35? 3:02. No, it's just not. I was looking at. I was right. All right, sayonara. See you tomorrow. Yeah, you're gonna have a really hard time this class if you're not writing stuff down. All right, e-learners, if you have any questions, send me your questions via email. And if you need any assistance, ask for it. Remember, there's going to be a quiz tomorrow. Your quiz will be online. Your quiz will be online. You'll see the details of it tomorrow. Later. What's up, Chris?
Matt didn't turn in.
Thank you. Matt.
I don't
You